Today's podcast is all about acids and bases. And if you've noticed, I've made acids red and bases blue. You'll see why in a minute when we start going over pH scales. So basically there's three different theories. There's the Arrhenius theory, Bronsted-Lowry, and Lewis. And today's podcast is going to focus on the Arrhenius theory. Now you already know about the Arrhenius theory. There's pH scales. You've also maybe heard of pOH. And you know that there's acids and bases. And then acids perhaps starts with hydrogen or have hydrogen in them, hydrogen ions. And bases have OH ions in them. Okay, so let's talk about, and again, we'll come back to Bronsted-Lowry and Lewis in another podcast. So what is an acid? An acid has hydrogen in it. It begins with hydrogen. So what could I use for an example? HCl. Oops, I should use a different color. Sorry, I'm going to use black. HCl, that's hydrochloric acid. That's an acid. Why is it an acid? Because it begins with hydrogen. HI, hydrogen iodide or hydriodic acid, is an acid. Why? Because it begins with hydrogen. Now what's a base? A base is something that ends in OH. So sodium hydroxide, right, that's how we name it. It ends in OH, so therefore it's a base. Under the Arrhenius theory. Remember, we're talking about this theory right here, Arrhenius today. What's another base? Well, I could have nickel hydroxide. Why is that a base? Because it ends in OH. So let's take a minute. If you don't want to do this next slide, go ahead and fast forward through it. But of these compounds, which ones are acid and which ones are bases? This is an acid because it begins with the letter H. Hydrofluoric acid. What's this one? It's a base. Why? It ends in OH. Iron hydroxide, iron Roman numeral 2 hydroxide. Right? That's how we'd name it. What's this next one? This is called acetic acid. Acetic, because this is the acetate ion, and acid, because there is an H at the beginning. If you need to review how to name acids, you can go back to my naming podcast. And if you said that this next one is a base, you are correct because it ends in OH, lithium hydroxide. You name the lithium, and you name the OH ion, which is hydroxide. So you need to be able to recognize what an acid is and a base. You're used to the pH scale, maybe, maybe not. And there's some stuff called litmus paper. Now if you notice, we're going to look at a couple different ones of these. I have a pH scale that can start with 0. Okay, so it starts with 0 up here, doesn't it? It goes all the way down to 14. And if you notice, this is litmus paper. Halfway in between, what happens? Isn't there a change right here from this red to blue? Okay, so that's why I've been doing red and blue all this time. I've been drawing a pH scale, or using the fact that an acid turns litmus paper red, and that a base turns litmus paper blue. Where's the changeover? Right in the middle. Okay, so acids turn litmus paper red, and bases turn litmus paper blue. Oh, let's look at the pH scale. You can take a peek and pause this. There's stomach acid, which is a pH of 2. Water, pure water, okay, has a pH of 7. Blood is around 7, a little bit over. Bleach, pH of 12. So there's different compounds that have different pHs. And you say, well, what does that have to do with me? Well, if you look, notice what the EPA puts out. They put a pH where all fish die. Bummer. That's not good. pH of 4.2. So you've heard of acid rain before. We can make an acidic lake by changing the pH by pollution. Rainbow trout begin to die around 6.0. Some frog eggs and tadpoles and crayfish and mayflies die at 5.5. So the pH of our environment affects animals, and it affects us. Here's some foods that are acidic and alkaline. That's another way you can, or term for a base. Interesting. Here's again another pH scale for food, and there's a thought, and it's true, that if you change the way you eat, you can change how healthy you are or not. And so look at this. Look at all the foods that you guys like to eat. Junk. And look where it lands. And I should be doing this in red. A lot of acidic foods are red. Donuts, soda, pastries, pasta. And then look over on this side. What's nice and happy on this side? All the fruits and veggies. And those are alkaline. So we are really meant to have an alkaline diet. Tooth decay increases below 5.5. So if you're drinking lots of black coffee, lots of soda, sports drinks. So if you're a sipper, you sip all this stuff all day long, then you're actually damaging your teeth, unless you brush your teeth. Now, what does a pH scale mean? It is a term that tells you how many hydrogen ions there are. So if you notice, this is a hydrogen ion. Okay, and again, this is a pH of 0. I'm kind of turning it sideways. And it goes all the way down until you get to a pH of 14. All right? And a base is how many hydroxide ions. See this right here? So if you look at these pictures, what's in the picture here? There's lots of hydrogen ions. At a pH of 7, they're pretty much equal. Do you see how equal they are? All the blue dots and the red dots are equal here. Here there's way more red dots, way more hydrogen ions, because I'm an acid. Here, what do I have? Lots and lots of hydroxide ions right here, because I'm a base. So it's true. From 7 down, right, if I'm below 7, so what's that mean? For a pH of 0 to 7, I'm an acid. What about a base? If I'm a pH greater than 7, so what's that mean? Greater than 7, so I could do this, couldn't I? Right? So what's it mean? If I'm greater than 7, so from 7 to 14, a pH, I'm a base. And it has to do with how many hydrogen or hydroxide ions are there. And if you notice, what's true? What's water? Distilled water is HOH. That's water. And look at that. That's because I'm an acid and a base combined, and they're equal. And so therefore, it's a pH that's neutral of 7. Now, if you notice on this scale, what's true? pH of 1, or 0, excuse me, there's a difference not of just 1, like 1 and 2 and 3 and 4. It's a difference of 10 times. So if you look at pH of 7, pH of 6 is different by 10. So imagine standing in one place and taking 10 steps. That's the difference between distilled water and saliva. Take 10 times more steps, so it's 100 steps away from 7. That's black coffee. So black coffee is not 2 times smaller. Okay, it's different by 100. So look at this. Different by 10, 100, 1,000, 10,000. This is 1 divided by. Okay, so the difference between the scale is not just by 1 point. And I'll show you a video later that you can look at, okay? If you're just watching this podcast, you can click on the link in a minute. If you're in class, we'll watch it. So increasing and decreasing acidity and basicity, how about that for a word? Here you go again. Here's my pH that's neutral. And what's true? A pH of 0, right? pH of 0. All you have is H+. There are no OH ions at all, are there? It's just H+. Now what happens when you move in this direction from 0 to 14? Look what happens. On a sliding scale, there's more and more OH ions present and less H+. See how there's some OH ions present here? Look what happens. What's happening in this direction? Aren't I adding more OH? See how OH is increasing and H+ is going down? And at this point right here, what's true? They're equal. So all the H equals all the OH. And that's when you're neutral. What about over here? Here I have all OH ions and no H ions. How come? Because I'm a pH of 14. So that's what it means. It's a scale. So let's go ahead. If you click on this site comes up. It's a really cool site. There's all kinds of cool things on here. I've already hit upload though. You'd have to go ahead and look at this, and you come over here and you press run now right here. Okay? And then it would download, not download, but it'll be able to run on your computer. I can talk. So I've got it on here. And if you look, let's look at the concentration and the difference between the hydrogen and hydroxide. Now, if you look right here, this, and I can't write on this because I just can't do it with this flip chart, but where it says H3O+, it's going to go away for a second. Wherever it says H3O+ ions, that really means I have a water with an extra hydrogen stuck onto it. So this is what water looks like. An extra hydrogen ion, right? That's our acid. It comes and sticks on there. So whenever you see H3O+, you have to think that's my hydrogen. So let's go back here. Okay? So my hydrogen, that's going to keep flipping back and forth, is the same thing as H3O+. And then I have my OH ions also. So look at this for a second. What happens when I actually move this scale? So what do you notice right now? If you notice, look at the red and the blue over here. See, it says H3O+ and OH-. So what's true about the H3O+ and the OH-? They're equal. So my H+ and OH are equal. And that makes sense because I'm at a pH of 7. Now let's go ahead and take it all the way into an acid. So an acid, oh look, I can go below. Wow, we'll come back to that another time. But look, a pH of 0. All right, what do I have? I could go ahead and do battery acid. That's a pH of 1. Right? But I'm making a custom liquid right now. See how it changes up here? Whoops, I can't flip back and forth on this. So what's my pH? If I have a pH of 0, look at my hydrogen ion and hydroxide. Look at that red line. I've got way more H+ ions, way less OH. So look what happens as I move it along. What's happening as I'm moving along my pH scale? More and more OH ions are in there, and less hydroxide. Excuse me, more and more hydroxide and less H+, correct? Isn't the blue increasing and the red is going down? So now as I'm doing this, I want you to look above this container where it says custom liquid and see the pH. Look at the pH. You can actually see the pH change. It's going at 0.1, 2, etc. But I'm sliding on the sliding scale. And look what happens. I'm adding more and more OH, less and less H. And what should happen when they're equal? I'm at a pH of 7. Now I keep going and I'm adding more and more OH and I become more and more basic. Oh, my pH is at the top of this scale as well. So do you see that? And I can have more, but we'll talk about that later again. So now we're going to go ahead and look at the molecules, or excuse me, the ratio of my H3O+ and OH-. So if you notice, they're pretty much equal. And if the bars are equal over here on the right-hand side, I keep flipping back and forth, I can't go on there, sorry guys. But if you look at this, let's go ahead and take it back so it's at 0. What do I have lots of? Wow. Look at that. I've got lots of hydrogen ions, my H3O+. Very few OH. Not enough to make a difference. I'm going to change the pH. What's that mean? That means I've got more and more, and they're moving around. More and more. I need to stop, I guess. So look what happens. I got more and more water, less and less OH. And look what's happening. They're equal. So what happens as I go up here towards the base? There's lots and lots of blue, that OH minus. So that's what I want you to picture. You can go ahead and fool around with this site and get comfortable with it. Okay? So again here, this is acidic and basic. If you look at this scale, it actually shows you what the pH colors are. So acid is red with pH paper, and it goes all the way to this purpley color for pH of 14. Perhaps you used pH paper before. You dip it in, and the color that shows up matches the pH. So if you want to, you can look at this Powers of 10 video, and it shows you very clearly what this means, that it's a difference of 1, and then this is it's by not by steps of 1 and 2 and 3. It's different by 10, and then 10 to the 10th of that. So it's, please just look at this, okay? It's hard for me to describe. We will watch it right now if you're in class, but if you're at home, just click on this. And then when you come back, you can go ahead and get on this page. So let's do some math. These are the equations. The equation used for finding pH, finding pOH, and an equation that relates pH and pOH together. If you notice, P means negative log. So P means negative log. And the H is my H plus ions, and my OH is my OH minus ions. And together they make an acid and a base. And look at this. They should equal 14, which is the pH scale, right? 0 to 14. Acid and a base. In the middle is 7. So let's do an example. Let's say I have a hydrogen ion concentration. Okay, this is given. My hydrogen ion concentration is equal to 1.2 times 10 to the third molarity. I would say to find the pH, and the instructions are to find the pH. I'm going to go ahead and look at my equations, and to find the pH, I do pH equals negative log of my 1.2 times 10 to the negative third molarity. And you put that on your calculator. We're going to do that in a minute. Now what if I had OH concentration, and the instructions were to find, and again, right now, we're not doing any math. I'm just showing you how you plug these in. Okay? So my instructions now are to find the pOH. So find pOH. And the molarity that you're given for my hydroxide ion concentration, remember those brackets mean molarity, is equal to 1.2 times 10 to the negative 6 molarity. I'm just making these up. So to find pOH, you look at your equations and you say, oh look, there's my pOH equation. What's pOH equal to? It's equal to the negative log of my 1.2 times 10 to the negative 6 molarity. And you plug that in your calculator. Again, I'm just showing you how to plug these in. Now what if I know the pH? What if in a different problem, the pH is equal to 2.60? What is the pOH? Well, I don't have a hydrogen ion concentration. I don't have a hydroxide ion concentration. What do I have? I have a pH. So what's the equation that relates these? It's this one. So again, our scale is 14.00 for our whole pH scale, right? 0 to 14, acid to base. So I'm simply going to do this. 2.60 plus x equals 14. So when you solve for x, what do you got in your calculator? Couldn't you also just say 14 minus 2.6? And that would be 11.4. And that's the POH. And we'll talk about significant figures later. All right, let's practice this. Okay, and I couldn't find a good online calculator, so I'm just going to go ahead and type stuff into this one. I'm going to rewrite our equations underneath, but for starters, we're going to just start finding the pH. So what do I have? I have my H3O ion concentration, and what did we say that was? That's really H plus, isn't it? So let's find pH first. How do I find pH? Well, I use my equation. pH equals the negative log of my hydrogen ion concentration. So I'm going to come over here on the scientific calculator, and I'm going to type in negative log, and you would press those on your calculator. You press the negative, the little plus minus sign. It's down next to the 0, and then the period, and there's a plus minus, right? You press that button. And then you find on the other side, you calculate over here, there's log and natural log. You press log. All right. Now, and what I'm going to go ahead and put in here is what pops up on your calculator. Oops, sorry. Well, I'll just leave this. So, log of my, and what we're going to do in the first one. Now, this is a really difficult calculator for me to use, calculator. So I'm going to take this 1.0 times 10 to the 9th, negative 9th. Right here. Goodness. Okay, there we go. And I'm going to turn that into a decimal. 0.0000. I don't know if it'll take it. 1, 2, 3, 4, 5, 6, 7, 8, and then the number 1. So when I put in 0.0, I'll get this. 0.00004, 5, 6, 7, 8, 9. Then close my parentheses. So look at that. What do I have? I have my molarity, don't I? I have my molarity as 1.0 times 10 to the minus 9th. And I've put it into my equation for pH. And now I'm going to go ahead and click equal on here. And it's equal to 9. So I have found that my pH is equal to 9. All right? So let's try that for another one. Get rid of this stuff. Okay, I'm going to go ahead and write this in. Get rid of this. Oh, that's not even what I'm... So pH is 9 here, wasn't it? All right. So let's try this one. What's my equation again? pH equals the negative log of my hydrogen ion concentration. Now, let's take this out of scientific notation, at least for this, because I can't put in this scientific notation. In your calculator, you would actually press, just so you know, negative log. Okay, that would pop in. Remember that plus or minus right here? Press that and then press log. And then that pops into parentheses on your screen. And you put in 1.78 times 10 to negative 4. Then close the parentheses and press enter. I'm going to do the long way. Okay, sorry. So on my calculator, I'm going to go ahead and put in 0.000178 molarity. So I'm going to come back up here. Instead of using my pen, I'm going to go ahead and just use my mouse. Okay, so I'm typing in negative log of my 0.000178 and close my parentheses. Press the equal sign, and I get a number that says 3.749. So we're going to round that reasonably. We're going to look at how many numbers are here. There's 3. So So I'm going to take those three numbers and put them here. 3.75. And that's my pH. Okay, so that's how you find pH. Let's find pOH. Now how do you find pOH? What's the equation? Well, what is it? It is pOH equals negative log of my hydroxide ion concentration. And again, I've got to take this out of scientific notation because the calculator I'm doing it on. So on your scientific calculator, you go ahead and put this in. So what is it? You're going to put in on your calculator, press that plus or minus sign, right? So you press negative log, the parentheses pops up, and you're going to go ahead and let's do this one. 3.55 times 10 to the minus 6th, and it's molarity, but then you close your parentheses. Now you're not finding pH, you're finding pOH. So let's go ahead and do this. You do it on your calculator, I'm going to do it on mine up here. And again, I apologize. I wish I could have found a calculator that I could work with, that I could actually type this at the same time, actually show you on the keys, but that's not the way it works. So, negative log of 3. Oh, I can't do that. So let's take this in scientific notation and go 0.0000503, right? 1, 2, 3, 4, 5, 6. Okay. So it's 0.1. Oh. 0.12345. Okay. Sorry about all these crazy things here. Move this out of the way. All right. So press my equal sign. Oh, I didn't close my parentheses, did I? That'll come up as an error on your calculator if you don't do that. So, what do I get on my calculator? I get, remember there's 3 numbers here, right? 3 numbers. So I'm going to write 3 numbers in here. So I get 5.45. It's not written really well. Sorry. So it's 5.45. That's my pOH. Okay? So let's go ahead. You try and figure out this bottom one, the 4.1 times 10 to the minus 2 molarity. I'm going to do it in my calculator. And I'm going to do this first. So I'm going to go ahead and take this out of scientific notation. Right, that's the same thing, isn't it? 0.041 molarity. I'm going to come up here. And what's my equation again? pOH equals a negative log of a OH minus concentration. So I plug this in. Make sure I close my parentheses on my calculator. Right, you're going to press negative log of 0.041, close parentheses, and you come up with this. 1 point, remember there's only 2 numbers here now, so I'm going to do 1.4. And actually, as far as pH and pOH is regarded to them, the significant figures are different. But for right now, let's just do this, okay? In my next podcast, I'll go into actually sig figs for pH and pOH. All right, so now what are we going to do? Because this is basic. So sorry I made that mistake, guys, but I'm not going to go back and redo this. So I'm going to go ahead here, and I'm going to clear my annotations. I'm going to go ahead and say, how in the world do we find pH and pOH? Well, we know that the pH is 9. So what's our other formula? Our other formula is pH plus pOH is equal to 14. So what's 14 minus 9? Well, I can do my crazy calculator up here, but you can do it on your regular calculator, and when you get 14 minus 9, or in your head, you get a pOH of 5, don't you? You know what I'm going to use a different color, so that way you can see what we've written in. This is a pH. pOH of 5. Now how did I get that again? I took 9 plus x equals 14. Okay? All right, now what? Let's go ahead and find the pH for the second one. This is 1, this is 2, this is 3, this is 4. So for number 2, we're going to find the pH. This information right here. So what do? You plug your information in, and you say, my pOH is 5.45 plus what? X. So 14 minus 5.45 equals 8.55 is my pH. I guess if I was sticking to my actual colors here, I would do this, 8.55. So how do I find pOH for number 3? If you said use this equation, you are correct. So I'm going to go ahead and take 14 minus 3.75, is that what that was? And I'm going to get 10.25. And for number 4, what am I doing? pH plus pOH equals 14. I knew the pOH is 1.4. I know my sum of everything is equal to 14. So I'm going to solve for x. I want to know this, the pH. So 14 take away 1.4 gives me 12.6. So my answer here is 12.6. Now, how do I figure out if I have an acid or a base? Well, what do we say about the pH scale? You should be able to kind of draw it. So what is it? 0 to 14. And neutral was in the middle, 7. Okay? So it's true. If I have something below 7, I have an acid. If I have something above 7, I have a base. And I'm not looking at pOH. This is not the pOH scale, it's the pH scale. So it's true. What's true is I look at this. This tells me if I have an acid or a base. Right, this is below 7, this is above 7. What if I have 7? Well, then I'm neutral. So a pH of 9 for number 1, what's the pH of 9 mean? That means I'm above 7, so I have a base. What's 8.55? It's above 7, right? Somewhere here. I have a base. What about for number 3? 3.75. Oh, that's below 7. It's somewhere around here. So it's true there. I have an acid. So if this bothers you, cover it up. So I'm not looking at that. I'm not looking at any stuff. Not this, or this, or this. I'm only looking here. So let's look at the next one, 12.6. Redraw your scale if you want to. Right? Here's 7. Where does 12.6 fall? It falls on this side. So greater than 7 is a base, right? This is an acid, and this is a base. So I have a base. So come back to this in a second. But very clearly, if I had a pH of 4 and a pH of 10, what's the pOH? 4 plus 10 equals 14 total. I have an acid. Why? Because this is below 7. What's this? A pH of 10 plus what? 4, right? Because pH plus pOH equals 14. What do I have? An acid or a base? Do you look at this? Say no. You look at this right here, and a pH of 10 is above 7, so it's a base on a scale of 0 to 14. So I have a base. Let's go back here and let's get rid of some of this junk. I'm going to get rid of this and this and this. Okay, all this stuff. And now what I'm going to do is I'm going to show you a different equation. And we'll come back in a different, actually we'll come back in a different podcast. And I'll do how to find OH minus and H3O plus and POH differently. So for right now, this is what you need to know. For extra credit though, we're going to do this anyway next week. Let me give you one more equation. There's something called kW. Oh look, that's equilibrium of water. And kW for water just so happens to equal 1.0 times 10 to the negative 14th. And our pH scale based on 0 to 14. How about that? Kind of a good way to remember it. And what's true, remember we saw that diagram before? I fooled around with that hydrogen hydroxide ion concentration. So when you multiply those together, they give you the kW. So let's go ahead. Remember, this was our H plus. So do we know? I want to find my OH minus. So we're not going to look at the rest of this for right now. Okay? I'm physically just going to look at how to find OH minus using this equation. Now what do you know? You know that kW is equal to 1.0 times 10 to the negative 14th. I'm going to give that to you. You know your hydrogen ion concentration. It's right here. It's 1.0 times 10 to the minus 9th molarity, right? That's what those brackets means, molarity. So what's true? Isn't my OH minus whatever that concentration is, don't you multiply those together? So you're basically doing what? Aren't you solving for x? Let's change that color. I'm solving for x. What is x equal to? And actually, let's stick with my color scheme here. My x is equal to my OH minus. Jeepers. My x is equal to my OH minus. Isn't that what I'm finding? I don't know this right here. So how do you do this? Solve for x. Don't you divide both sides by 1.0 times 10 to the minus 9th? So I'm going to go ahead and I'll pick red to do this with. Divide by 1.0 times 10 to the minus 9th. Divide by 1.0 times 10 to the minus 9th. That cancels. And when I do this on my calculator, I can do this on my calculator where I can say negative 14 minus a minus 9. That's what you do because you have exponents. If not, you can put this in your calculator. You can put in 1.0 times 10 to the negative 14th, right? Press that little negative button, the plus minus button down here, you know, the negative. And then you put this in parentheses, and you're going to say divided by 1.0 times 10 to the minus 9th. Close your parentheses. And what do you get? Give me a chance to do it. I get 1 times 10 to the minus 5. And again, let me stick to my color scheme. 1. I am not having a good day. Actually, I am, but not with colors. 1.0 times 10 to the negative 5th. And look what would have happened if I had done this. I look at my exponents, that's a minus 14th, and when you divide, you subtract your exponents. So it's negative 14 minus a minus 9. Isn't the same thing as negative 14 plus 9? And what do you get? Minus 5. And that's your exponent right here. So let's get rid of this mess, and let's try this again. So what's my equation? Kw equals all the hydrogen ion concentration times all the hydroxide ion concentration. I'm going to use that to do what? In this one, I'm going to have 3.55 times 10 to the minus 6 for OH. And now I don't know hydrogen ion concentration, do I? Right? And so I'm trying to find right here, and this is my X. I don't know this. My question. So that's equal to Kw, which is equal to what? 1.0 times 10 to the negative 14th. And so in this case, I don't know my hydrogen ion concentration. That's my X, isn't it? So how do I find it? I do math. I'm going to divide both sides by 3.55 times 10 to the minus 6. 3.55 times 10 to the minus 6. This cancels. I put this in parentheses. Now I need to do math because I don't have ones anymore. So I'm going to go ahead and take 1.0 times 10 to the negative 14th divided by, in parentheses, 3.55 times 10 to the minus 6. Close my parentheses, and I get, for my answer, 2.82 times 10 to the minus 9th. And actually, if I look at my significant figures, I don't include this 2. If you don't sig figs right now, don't worry about it. Now, I'm finding my hydrogen ion concentration, right, in these brackets. What those brackets mean again? Molarity. So that equals my hydrogen ion concentration, which is the answer which goes in this blank right here. Right here. This is the answer. So you go ahead and try the next two. You try number 3 and number 4. I'm going to go ahead and do them on the board up here while you work. Remember, your equation is Kw equals 1.0 times 10 to the minus 14th. And I'm sorry, I'm trying to be weird about doing this lettering thing with colors, but it might help you. And it's not cooperating. Black pen. Kw equals 1.0 times 10 to the minus 14th. My equation is Kw equals 1.0 times 10 to the negative 14th equals H plus OH minus times OH minus. So if you want to pause this, you can. If you want to keep watching it, you can also. So I'm going to do number 3 first. In number 3, I'm finding my OH. I don't know this. That's my X. So there's my X. What do you know? You know your hydrogen, don't you? You know you have 1.78 times 10 to the negative 4th molarity. You know that's equal to 1.0 times 10 to the negative 14th, excuse me. It's been a long day. And then I solve. How do I solve? Don't I divide both sides by 1.78 times 10 to the negative 4th molarity? And this is molarity here also, so you don't need to worry about the molarity when you're doing this, but just so you know what it is. This cancels, and I divide. In my calculator, 1.0 times 10 to the negative 14th divided by 1.78. Oops, you need to put in parentheses, don't you? 1.78 times 10 to the negative 4th. And that will give me 5.6. So my X is what? My X is equal to my OH ion concentration, OH minus. And the answer is 5.62 times 10 to the minus 11 molarity. That's what goes in this blank right here. Last one. Let's find this. My hydroxide, my hydronium or my hydrogen ion concentration. What is true? Well, I need to go ahead and use my equation. What's my equation? That's just squeaky squeaky. My equation is what's listed above. Now I'm going to go ahead and take this number. I'm going to forget the colors. Take that number, and what am I going to do? I'm going to take 4.1 and put it here. This is my 4.1, right here, times 10 to the minus 2 molarity. Why am I putting it here? Because it's my hydroxide ion concentration. What do I need to find? I need to find this, don't I? I don't know my hydrogen ion concentration. So I need to find X. What's that equal to? 1.0 times 10 to the negative 14th. Do your math. What do? Divide both sides by this. Cancels. And on your calculator, 1 divided by 10 to the negative 14th divided by, in parentheses, 4.1 times 10 to the negative 2. Close your parentheses. And you should get 2.4. This answer right here is 2.4 times 10 to the 15th. Okay? And that's how you do KW.